Don't be afraid. Don't be scared. It's not coal. It's an amazing biochar. As you can see, there's 300-gram bag of biochar, equivalent to what Tim's pouring in, contains 1 kilogram of carbon dioxide removal. Let's unpack that. Thank you, Tim. So I'm going to cover off on who's ANZBIG, how biochar will decarbonise agriculture and its the many ways that it can do that. Pyrolysis of agricultural residues and what's that all about, and how biochar can be used in soils and animals to decarbonise agriculture. So let's go to that. So firstly, ANZBIG has a roadmap that aims to transform 50 million metric tonnes of biomass waste, agricultural residues per annum to biochar, emission avoidance, energy and carbon removal. So the biochar would be around 10 million tonnes, the emission avoidance energy is around 300 million gigajoules, and the carbon dioxide removal is equal to about 25 million metric tonnes annually. We want to scale this up by 2030, and we have the technology to do that. So we have over 200 members in ANZBIG and we're growing. 10 of those have the technology with the ability to scale the industry and pyrolyse that 50 million metric tonnes of biomass waste. That's your biomass waste that can be turned into significant revenue as well as remove and decarbonise globally. In fact, the industry globally suggests that it can remove around 10 to 30% of global carbon emissions. So I'm going to talk firstly about pyrolysis and how that can remove carbon as well as avoid emissions. Then I'm going to talk about how biochar can increase soil carbon as well as reduce nitrous oxide and methane emissions from the soil. And then I'm going to talk about how biochar fed to animals can reduce methane emissions from the animals and its manure, and also reduce nitrous oxide emissions from its manure. So let's go into pyrolysis. Very simply, we feed biomass waste. So for example, if we fed 5,000 tonnes per annum of biomass waste, and there is a case study project from Metamorph, for example, that's going to do this in January, who I also work for. So 5,000 tonnes of biomass waste will be fed through a pyrolysis system in the absence of oxygen, different to combustion. Combustion uses oxygen, the carbon dioxide goes into the atmosphere. When you pyrolyse biomass, the carbon dioxide goes into the biochar, stays in the biochar, it's permanent, it's highly measurable, it's highly auditable, and we sell that on the voluntary market for a minimum of $200 per tonne for the carbon dioxide removal. So the outputs when it goes through the machine is around 25 to 30% of biomass as biochar, which is saleable, but also highly utilisable and probably worth more by applying it to your property than it is to sell. The carbon dioxide removal, so the biochar contains around 95% carbon, and then of that, you times that by 3.67 to get your carbon dioxide removal equivalents. Then you need to take off your footprint to produce it. So around about 2,500 tonnes of carbon dioxide removal per 1,000 tonne of biochar. And then in the process, it also generates thermal energy, which can be converted to electricity or utilised to replace steam or hot water. So a lot of the projects work with things like sugar mills that need steam to produce sugar, or timber mills that need steam to dry timber. But also that energy, with larger technologies, can be converted to electricity. And some of the other technologies, instead of producing that, they produce syngas, which can be turned into ammonium, renewable fuels, and other renewable types of energy. So from 5,000 tonnes of biomass waste, 5,000 tonnes of biomass waste can generate around $1.3 million per annum. So the message that I think collaboratively we need to get out there is carbon dioxide removal equals an improved economy as well as decarbonisation. So here's some of the technologies within ANZBIG that can help with that process. So, you know, as I said, we've got 200 members, but we've got 10 pyrolysis manufacturers that sell off-the-shelf technology that is multi-million-dollar technology, some of it's less than that, that can pyrolyse biomass waste. All of the technologies are different, they have a different offering, and the only way to compare the economic benefit really is to do a financial feasibility. So we have energy farmers in Western Australia that have, you know, generated technology, Earth Systems, Paracal here today, Rainbow Bee Eater in the southeast, carbon-coated mineral complexes, CETA that promises to make lots of different types of renewable fuels, Metamorph technology, we're here today, Damien's in the audience, we have a booth, so please come and see us. We've got 2 different types of tech, and Pyroco and Renergy. So the reason for putting that is because, you know, I'm here to represent the industry, and you know, you've all got access to the slides, so here's all the contacts if you want to follow anybody up. So I'm going to go on to biochar decarbonisation in the soil. So let's get into that. So firstly, 50% of soil carbon, might be more now, because 5 years ago I came to a conference, Louisa, and that's what I remember is there's an opening presser that said 50% of global soil carbon has been released to the atmosphere. Is it still the same, or is it more now? Not sure. So it's in the atmosphere. We need to recycle carbon. So the very ethos of biochar is that instead of letting biomass rot or be burnt, we can pyrolyse it and turn it into permanent carbon dioxide removal that you then can put back into agriculture and in the soils to recycle carbon. And with every 1% you increase your soil carbon, you can increase productivity and water holding capacity by 10 to 30%, depending on the soil type. So we need to get carbon in your soil, biochar, get it into your soil. So there's a meta-analysis that was done by Stephen Joseph, who we call the godfather of biochar. He's looked at 14,000 published papers, and consistently with all these different trials, there's over 70,000 published papers on biochar. On average, it showed for every kilogram of biochar that you apply to the soil, the carbon in the soil on top of the carbon in the biochar more than doubles due to what we call a negative priming effect. And in fact, if you apply it, we suggest in broadacre agriculture at around 300 kilos per hectare per year, you keep getting this ongoing cascading benefit. So you might apply 300 kilos, that will double, you know, maybe over 2 years, but the benefit keeps continuing getting better every year. So you might find a better benefit in the 2nd year and the 3rd year and 4th year. And if you keep applying 300 kilos, you get this growing benefit of increased soil carbon. You apply a bit more, you increase the soil carbon further, and slowly and very amazingly, all of the amazing things that happen in the soil, which I'll explain in a further slide, will unfold. So things like, you know, 1 gram of biochar has the surface area of a house. It has huge pores that act as a bucket, if you like, to both hold the water, but it also has an electron mediating surface, both a cation and anion exchange capacity that holds onto the water from an electronic perspective, like a magnet. It also provides a bucket for the microbes, and the microbes will then benefit in the soil. Highly published and highly cited, that negative priming effect. So biochar can also reduce nitrous oxide emissions from the soil. That's also a meta-analysis. It can do that by improving fertiliser use efficiency. It increases nitrogen fixing bacteria as well. but it also alters the soil microbial communities and improves nutrient retention, which means there's less nitrogen or nitrous oxide lost to the atmosphere. It absorbs ammonium and nitrate ions because of its electron-mediating surface, reducing nitrogen leaching. And it increases soil pH, so it actually is beneficial for soil pH, favouring microbial pathways that then produce less nitrous oxide. But one of the other amazing global trends of biochar use is applying it with synthetic fertiliser. We've just imported the most amount of synthetic fertiliser in Australia ever, and the price is going up. Last I checked, it was around $1,200 per tonne of synthetic fertiliser. These amazing two studies by Yi and Bai, which studied over 80 different serial studies of biochar and synthetic fertiliser, showed that when you apply just 20% of biochar with synthetic fertiliser, you'll get another 20% increase in yield. So to unpack that, biochar alone potentially increases yield by around 20%. Synthetic fertiliser alone will increase yield by around 25%. But when you combine both biochar and synthetic fertiliser together, it'll increase yield by 42%. And that's across 80 different papers in a meta-analysis. What it also showed was that you could half your fertiliser rate with just 20% addition of biochar. So that alone is an amazing fact, and there's a lot of farmers that are really interested in acquiring biochar to apply with their synthetic fertiliser. Okay, let's talk about how biochar reduces methane emissions now. So biochar does play a significant role in mitigating methane emissions from the soil because it aerates soil, which is crucial for the growth of methanotrophic bacteria that consume methane before it escapes to the atmosphere. Methane, we know, is 25 times more potent than carbon dioxide, so that's very important. And that's highly published as well. It also improves microbial activity that supports the growth of the bacteria as well, which are responsible for methane oxidation in the soil. So just summarising, so I talked about how biochar in the soil can increase soil carbon and reduce methane and nitrous oxide emissions, but it also has these amazing soil and plant health benefits that I touched on, including aeration, improving soil structure, because you've got to imagine the porosity and how it can allow that permeability of water through the soil and microbes, but it also, breaks up the soil and pulls it apart, improves plant health, root growth, increases microbial activity, increases fertility, fertiliser efficiency, nutrient cycling, liming effect because it actually has an alkaline, it's alkaline in nature, so it actually can be used as an alternative source to lime, improves seed germination. In fact, because it is like a magnet, it will coat seed and it will hold nutrients next to the seed and increase germination. Really important on non-wetting sands, like what I have. I also am a beef producer. It helps with water supply, increases yields. It absorbs PFAS and heavy metals from soils. It's used in mining sites to absorb mining tailings, as well as improving the sustainability and returning that soil back to normal. Pest management as well, and disease resistance. Okay, so let's just talk briefly about how biochar can be used to reduce methane. Stuart's covered off on it as well, and reduce nitrous oxide from manure and all the animal and health production benefits. So adding biochar animal feed absorbs methane producing microbes and naturally lowers methane emissions from digestion. It also supports better gut health, and then therefore better feed conversion. It has a redox active process. It actually neutralises the pH of the rumen, allows better feed conversion to weight gain. And it can be added to manure to help trap methane, lowering greenhouse gas impacts from animal agriculture. I've done a number of studies and I actually used Stuart's biochar in the early days. And for example, we fed biochar at just 150 grams per head per day to dairy cows for a year, and we had an increased milk yield from 0.4 to 1.5 litres per head per day. It was actually more in the younger animals because their rumen was developing still. We increased milk, fat and protein, and we also reduced the fodder intake, so we got better feed conversion. But amazingly, so we also had things like less mastitis. The dairies didn't smell anymore. There was a stink when you go to some dairies, it didn't smell anymore. It was sweet smelling, in fact. What's amazing is the biochar stays in the manure of the cow. And then we measured the manure and found that the manure was higher in nitrogen, potassium, phosphorus, minerals, nutrients. So it's this like bioactive manure that the cow is spreading across the landscape. And then dung beetles incorporated that into the soil. I then went on and did some further studies looking at the soil health and found that the soil carbon, all of those amazing things, the mycorrhizae fungi were greater, the soil carbon, the yield was far greater than even, biochar, dung buried without biochar in it. All statistically significant results right across the board. So to feed biochar through an animal is an amazing way to have this ongoing cascading benefit to, reducing all of your emissions across the farm. And when we have this ability to gain an integrated decarbonisation payback from farms, that's where that will come in as well. You would do it because you're just going to increase your farm health and productivity and production, but you're also getting all these other amazing decarbonisation benefits in an ongoing, cascading, growing way. So if you want to just acquire some biochar and play around with it and, use it, get it in your soil. These are all the different biochar suppliers that are right across Australia. And the availability of biochar is increasing as we speak with all these amazing technologies that are out there. So, we are, suggesting that, at the moment there might be 40,000 tonnes of biochar available. In another year, that's going to more than double. Then it's going to quadruple until we get to our roadmap that we aim to achieve. As an industry group, we're doing a lot of advocacy, and I'll touch on that shortly. But to summarise what I've talked about is that our biochar industry group is not just biochar, but just biochar is amazing. So instead of giving all the naughty kids in your household a lump of coal this year, please give them what I did, and I did this to my family last year. I gave them all a kilogram of biochar, and I told them by putting that in their soil so that the biochar contained a kilogram of carbon dioxide removal, but if they were to put it in their soil, they would contribute to another 3 tonnes of carbon dioxide removal. So 4 tonnes equivalent. It's a quarter of their carbon footprint for the year. So, so that by going and putting it in their soil, they've done something good. And so, those people that you find hard to give gifts to, I just bought a bag of biochar and went, here's your bag, here's your bag. I gave them a piece of paper. Right. So, and you can feed it to your dogs if they've got smelly poo, do that. It's amazing. So, pyrolysis, so biochar is more than just biochar. It has amazing impacts, but when you make it, you also avoid emissions. Then you can feed it through animals, you can increase soil carbon, reduce methane and nitrous oxide, and you can lower emissions from both livestock when you feed it to them and from their manure. From 5,000 tonnes of biomass waste, you can generate around $1.3 million, and then you can go on to use the biochar in your soil to do all those amazing things. Further increase revenue, improve production, fertiliser and water savings, soil carbon payback, and farm decarbonisation rewards. So a shout out to the amazing Australian New Zealand Biochar Industry Group. executive board and our advisory board, the amazing Tim Charlton, who came up on stage earlier to pour the Biochar in. So we have 10 exec board members. We have 5 advisory board chairs. Adam O'Toole's also in the audience, Soil Sequest, he chairs the Standards and Certification Committee. Tim chairs the carbon one. So we have 10 goals that we aim to achieve to get to our roadmap by 2030. And each of the chairs are responsible for 2 of those goals. They're primarily doing that voluntarily at the moment while we revenue raise. We need to, we suggested we need around 150 million to achieve our goals. In Denmark and America, for example, biochar is subsidised, but Denmark actually taxes waste polluters and puts it into a fund. They've got a $5 billion fund that subsidises pyrolysis and biochar. These are some of the advocacy points that we aim to achieve. We're a growing industry. We're expanding rapidly. So please come and see Tim at the Anne's Big Tent. We're here as well, right next door. Damien and myself from Metamorph. Adam's here. We've also got this amazing Bible we call, which is available online and also at the tent. It's got all amazing summarised research, all of the pyrolysis technologies, biochar providers, anything you need to know about biochar is in this Bible. So thank you.